Now my dear students, we can see the question number 16. Which one of the following statements for the order of reaction is incorrect? Order can be determined only experimentally. Yes, this is the correct answer. Order is not influenced by stoichiometric coefficient of the reactants. Yes, not influenced. Order of reaction, sum of the power to the constant terms of reactant to express the rate of reaction. It is a definition of order of reaction. Definition of order of reaction you can see. And number D, order of reaction always whole number? No, not at all. Order of reaction may be, my dear students, negative, and maybe, my dear students, negative, maybe minus 1 by 3, minus 1 by 2, it maybe it's a fraction number. So it's a wrong answer. Now my dear students, we can go to the question number 17. The unit of rate constant of a zero order reaction. My dear students, I give you concept and tricks to calculate the unit of all order of reaction, all order of reaction. My dear students, you can see the concentration. Here concentration की power 1 minus n into time inverse. You can learn this formula, and here you can get this order of reaction. Here n is the order, my dear students, it is the order of reaction. And here concentration. Concentration, we can take the concentration in moles per liter. Here, my dear students, you can see here for zero order reaction or zero order reaction. Concentration, you can put the moles, mole per liter, की power 1 minus 0 into time inverse. Generally, my dear students, time is taken in a seconds generally. So you can see here mole per liter. So this is the moles, liter inverse and second inverse. This is the unit. We can get the unit by this formula. Concentration की power 1 minus n, time inverse, and you can get this answer. Mole, liter inverse and second inverse. So you can go the option A. Here in option A, you can get the mole, liter inverse, second inverse. And you can calculate the, my dear students, unit for first all order of reaction, first order reaction. For first order reaction, mole per liter 1 minus 1 and second minus 1. So you can see here mole per liter 1 minus 1 means 0, any power 0 is 1, and here you can see the per second. So for first order of reaction, you can see here for first order reaction, you can see here this is the per second is the unit. You can calculate the second, third order reaction by this formula. So my dear students, you learn and remember this formula, it's a very, very important, and this is a trick. Now we can go to the question number 18. Here, my dear students, you can see during the kinetic study of the reaction, twice A plus B to give C plus D, following results were obtained. Here, my dear students, in this type of questions, first of all you can see the experiments. Those experiment in which concentration, A concentration is constant and B is changed, and then you can see the initial rate and calculate the order of reaction. Here we can see the experiment number 2 and 3, concentration of A is constant, but here you can see the concentration 0.2 to 0.4 double. When concentration double, and you can see here this concentration is double and this rate is increases by 4 times. When concentration double and rate of increases in 4 times, it means for the B it is a second order reaction. Why? Because when concentration is double, then rate of increase is 4 times, 2 2s are 4. So then rate is increases the 4 times. So we can see here constant the concentration of A and B concentration is double and rate is increased by 4 times. So, for B it is a second order reaction. Now, we can see the order of reaction for A. We can see the concentration of A is constant, here 0.1 first experiment and fourth experiment. Concentration of B is constant, and here you can see the concentration of A is increased by 4 times. When concentration of A is increased by 4 times, you can see here, my dear students, here rate is also increased by 4 times. So, this is the first order reaction. So, my dear students, it is the formula of this question, B ki power 2 and A ki power 1, and my dear students, you can go the option D. Here in this option you can get the rate is equal to A ki power 1 and B ki power 2. Now, my dear students, we can go to the question number 19. Here, for the reaction A plus B, product is observed that on doubling the initial concentration of A, only the rate of reaction is also doubled. It means doubling the initial concentration of A, only rate of reaction is also double, means it is a first order reaction. You can see here, here are the first order reaction. Here A and C option, here D and B and D are omit, because here you can see the second order reaction. So, you can see only you can see the A and C option, here first order reaction. Now, we can see on doubling the initial concentration of both A and B, there is a change by factor of 8 in the rate of reaction. So, my dear students, you can go the question number 19 A option. Why? Because doubling the concentration of A, concentration rate of reaction double, and total is 8. So, it is a second order, 2 2s are 4, 4 2s are 8. So, total rate increases by 8 times when it is a second order reaction. So, my dear students, you can go the question number 19 option A, and this question is also asked in 2009, my dear students. Now, we can go to the question number 20. Here, my dear students, the bromination of acetone that occurs in acid solution is represented by the equation. Here, it is the same question. You can see the concentration here and change in concentration. Here, rate, it depends upon only rate is equal to K, and reactants, you can see here reactants acetone CH3, COCH3 and Br2. So, my dear students, you can see here, this is wrong answer because H plus ions are present, it is a wrong answer. So, here you can see here H plus ions is present in the product. Now, we can see here this H plus ions is present in the product, and initial rate, it is also a initial rate. So, you can also calculate the H plus ions which are present in a product. So, we can see that. Here, my dear students, H plus ions and rate, if 1, so first order reaction 1 first order and 2 second, we can see, we can determine the concentration and rates. Here, first of all, we can determine the acetone. Here, perhaps, my dear students, acetone is a first order reaction by the scene of these 4 options. You can see 1 1 1 1. So, it is a first order reaction, you cannot find out, do not waste your time. Now, we can see here Br2, do not waste your time in Br2. You can, if you can see the Br2, if Br2 is not present in H plus ions, so if answer is C, then you can see when Br2, okay, acetone concentration, Br2 is double, here you can say 1 and 2, you can take here 1 and 2. Here you can see here concentration of acetone is constant, concentration of H plus ions is constant, but here we can double the concentration of Br2, then we can see the rate of reaction. Here you can see, my dear students, rate of reaction is unaffected, rate of reaction is same, unaffected. If rate of reaction is same, it means, my dear students, it is a 0 order reaction for Br2, and when it is a 0 order reaction, any power of 0, it gives 1. So, my dear students, this is not come in the option. So, only you can get the option C, because here Br2 is not present, and in another option you can see the Br2. Now, we can verify this is also acetone and H plus ions. Here you can see the order of reaction of H plus ions first. Here you can see the constant, this 0.05 and 0.10. Here this is the constant Br2, and here this is also constant. When the double the concentration of this 1, 2 and 3, 2 and 3, then we can see the 2 and 3, this is the rate of reaction. When double the concentration of H plus ions and constant the concentration of Br2 and acetone, then you can see here 5.7 and 1.2, 5.7 and 1.2 into 10 to the power minus 4 means double the concentration of. If 5.2 is multiplied by 2, you can get the approximately 1.2. So, you can see here, this is the H plus ions, by the H plus ions you can see here, this is the first order reaction for H plus ions. So, Br2 is not present, and when Br2 is not present, then option number C is present. Here Br2 order of reaction is 0 for Br2. So, it is a 1. And for acetone, here when the double the concentration of 0.3, 0.40, for acetone it is also a first order reactions. It is not double the concentration, it is just slightly increased by 0.10, and here it is also increases, So, you can find out by this formula for acetone R1 is equal to K into acetone. You can put the R1, other are constant when others are constant. These are not constant now, 0.10 and 0.05, 0.10 and 0.05 here are not constant, but other are constant. Then you can put this type of formula, acetone of all 0.30 concentration, and here X, and R2 is increases by R2 here, R1 is the 1.2 into 10 to the power minus 4, here R2 is the 3.1 into 10 to the power minus 4. When you divide it in this way, K is cancelled, and write the concentration of this 0.30 and 0.40. These are the concentration is change, R1 R2 is change. Then you can calculate this concentration. So, you can also get the option C, that is the, because you can get the first order reaction. So, my dear students, we can easily calculate the concentration and order of reaction by the use of these formulas. Now, we can show the question number 21. My dear students, this question number 21 is also important. In question number 21, here you can see the reaction of hydrogen iodine monochloride is given. The reaction is of first order with respect to H2 and ICl. Following mechanisms were proposed. Here you can see the mechanism of mechanism B. Always you can see the order of reaction. Always determined by slow reaction. Order of reaction always determined by slow reactions. So, my dear students, here you can see the slow reactions. Which of the above mechanisms can be constant with the given information about the reaction? Here you can see the A reaction. Here this is mechanism of A and mechanism of B. Here HICl and HCl is formed and iodine is evolved. These are also evolved in this section, and it is a fast reaction. So, you can get the order of reaction by slow reaction. So, only B only is the correct answer. It is a theoretical question and you can easily solve it, and this is the concept of this theory. Concept is this: order of reaction is always determined by slow reaction. You can see the different type of reactions or steps are present. You can see the slow steps, and in this slow step, because equilibrium is not there, so my dear friends, you cannot see the other reactions. You go to the slow reactions. So, option is B only. Now, we can see question number 22, my dear friends. The rate of reaction between two reactants A and B decreased by a factor 4 if the concentration of reactant B is doubled. The order of the reaction with respect to reactant B is. My dear students, here you can see the the rate of reaction between two reactants A and B decreases by, here you can see that decreases by a factor of 4. Here when 4 R1 upon R1 is equal to, here my dear students, K A x into Bx upon K Ax into 2Bx, because here you can see here two reactants A and B decreases by a factor of 4 if the concentration of reactant B is doubled, only B is doubled. So, we can take the two reactants, but this is constant, so it is a cancelled. So, you can see here my dear friends, 4 is equal to 1 upon 2 into x, B and B cancel, 1 upon 2 x. If you can put the 1 upon 2 minus 2, then you can get this 4. So, my dear friends, answer is, this is the order of reaction here. This represents the order of reaction. So, our order of reaction is the minus 2 for B, because A is a constant here and only concentration of B is changed, and by that change of concentration, rate of reaction between two reactants and B decrease by factor 4. Now, my dear friends, here we can see the question number 23. If the rate of reaction is equal to the rate constant, the order of reaction is, my dear friends, here you see the concept, and this concept you can further write. For 0 order of reaction, rate of reaction is equal to the rate constant, or rate of reaction is not depends on the concentration of the reactants. So, my dear students, here you can see the, so here rate of reaction is equal to rate constant. So, my dear students, it is a 0 order reaction. Question number 23, you can go to the 23-0. Now, my dear students, we can see question number 24, 2A to give B plus C, it would be 0 order reaction when? My dear students, it is a 0 order reaction when twice A to give B plus 0. 0 order reaction means rate of reaction is not depends upon concentration of A. So, my dear students, you can go to the question number 24th, that is a B, the rate of reaction remains same at any concentration of A, because it says 0 order reaction. It is a basic concept, basic points, basic definition of 0 order reaction. 0 order reactions are not depends on the concentration of the reactants. 0 order reactions are not depends on the concentration of the reactants. So, my dear students, it is a important point for you. Now, we can go to the next question. Now, my dear students, we can see the question number 25. For the reaction twice N2O5 for NO2 plus O2, rate and rate constants are here. My dear students, you can see the, what is the formula of this question, that is the rate that equal to here K into N2O5. My dear students, this is the first order of reaction, that is, so you can not put the this 2 here, you cannot put the here 2, because it is a first order of reaction. Here, my dear students, rate is the 1.02 10 to the power minus 4, and here rate constant 3.4 10 to the power minus 5, and here he wants the concentration of N2O5. My dear students, this concentration of N2O5, when you can calculate N2O5 concentration, then you can divide this 1.02 into 10 to the power minus 4, and that is divided by 3.4 into 10 to the power minus 5. Now, my dear students, when you can divide these values and you can get this 3. So, my dear students, when 1.02 is divided by 3, then you can get 3.4 10 to the minus 5. So, this is the concentration is 3 for this question. This is a question number 25, and this question is also asked in the 2001 NEET exams. Now, we can see the question number 26. The experimental data for the reaction twice A plus B2 2 gives twice AB is. My dear students, you can see here this experimental data. First of all, you can see the constant of A, and you can see the here double the concentration of B2. So, here double the concentration of B2 and double the rate. So, it is a for the B, it is a first order reaction, and for B is the first order reaction. You can see BA is the first order reaction. So, here D is not answer, here D, B is the second order, so it is not answer. Here C or B is the answer. So, we can find out the A. When A is found out, you can see the constant concentration of B, that is 1, and here concentration of A is doubled and concentration of B is constant. And when concentration of A is doubled, my dear students, concentration of B is constant means rate is not depends upon A. It means rate is independent of A ki power 0. So, this rate only depend upon this B. So, you go to the answer C, rate is equal to K into B, because here you can get the order of reaction 1. Double the concentration, rate of reaction is double, that is why order of reaction is double. Then you can go to the answer C. My dear students, this is question number 26, and you can get the answer C. Now, we can go to the question number 27. 27 is a theoretical question, my dear students. Here no rate of reaction, here no data is there, because rate of reaction or order of reaction is only a experimental value concept. My dear students, order of reaction only determined by experiment. If experiment is not given, then you cannot get the order of reaction. But here you can not get the experimental data. Simply this reaction is given for this question. So, my dear students, we can simply this 2 is power 2 and this 1. So, 2 plus 1 means you can go to the third order reaction, because here this is not a correct pathway or correct this point or correct this formula. But if you have not given in the data in the question, what happened? So, my dear students, you can go, this is the last option, is that you have 2 is present here and here 1, 2 plus 1 3, that is why you can count the third order reaction, because here we can see the 2 molecules of FeCl3 reacts with 1 molecule of SnCl2 and form the FeCl2 and SnCl4. So, my dear students, you can see the question number 27, option is A. Now, we can go to the question number 28. Here in question number 28, data is given. So, you can see the data and get the answers. Here first of all, you can see this 0.04, it is a constant, and double the concentration or half the concentration of 0.03, 0.70 to 0.035. When, my dear students, you can half the concentration of B, then you can see here your concentration initial rate is just 8 times decreases, half the concentration, and this is 8 times decreases. Now, we can see here when this is the concentration is here 0.03 to 0.035 constant for B, and you increase the concentration of this A, it is a concentration of A is doubled 0.012 to 0.04, 0.024. It means, my dear students, you double the concentration of A but you constant the concentration of B, then you can see here initial rate is not changed. If initial rate is not changed, means rate is not depends upon A. It means it's a zero order reaction for A. A is a zero order reaction, or when A is a zero order reaction, so you can see here A and B option is not correct answer. Only C and D option is the correct. Now we can see the C and D option. R1 is equal to K into concentration of B. My dear students, R1, you can take the concentration of 1, that is 0.070. 0.070 concentration, you can get the 0.070 concentration, that equal to K, when initial rate is, here concentration is 0.70, and initial rate you can get the initial rate, that is 0.80. So you can get the initial rate 0.80, that equal to K into 0.70. Now my dear students, let's say R1, and what is R2? R2 when 0.10, this is the R2. R2 is the 0.10, and concentration becomes that equal to 0.035. My dear students, you can divide these concentrations with this rate, K and K is cancelled. When K and K is cancelled and 0.80 upon 0.1, means this is the 8 is equal to, here this is a 0.035, 0.070. Here you can see here, this is the, my dear students, 0.070. So here these points are cancelled. So you can 35 divided by 2 ki power x, because here x is present, we can determine the order of fraction of B. Then my dear students, if you can 2 ki power 3, then 2 ki power x, you can see it's a simplify. You can write this equation in this way. It means this x, my dear students, this x is denote the order of fraction, and here order of fraction is 3. So my dear students, for B, order of fraction is equal to 3 for B. So you can go the answer C, that is the question number 28, you can go the answer C. Now my dear students, we can go to the question number 29. Here this question is asked in NEET 2020 exam. Here the rate constant of a first order reaction is 4.606 into 10 to the minus 3. This is a rate constant. Here you can see the rate constant means K, 4.606 into 10 to the power minus 3. And my dear students, here the time required to, here he want the time t, required to reduce 2 gram. 2 gram means A is equal to 2 gram. Of the reactant to 0.2 gram means A minus X is equal to 0.2 gram. So my dear students, you can see here K is equal to 4.60, 6 into 10 to the minus 3. Time is equal to A is equal to 2 gram and A minus X is equal to 0.2 gram. Now we can see here, my dear students, this is the formula of first order reaction. K is equal to 2.303 upon T log A upon A minus X. Now you can calculate that T is equal to 2.303 upon K log A upon A minus X. Now you can put these values in this formula. T barabar 2.303 upon K, that is 4.606 into 10 to the power minus 3 log A is the 2 upon A minus X is the 0.2. My dear students, when you can get the 0.2, 20 is present, and you can solve this. This is a 10, here 10 is obtained, log 10. Here my dear students, 0.303 is given to 2. When this 2.303 is multiplied by 2, then you can get the 4.606. So my dear students, you can solve this problem for T. Here 1 upon 2 into 10 to the power minus 3, here log 10, and my dear students, log 10 that equal to 1, here log 10 is equal to 1, log 10 that equal to 1. So my dear students, it said T is equal to 1 upon 2. 1 upon 2 means that is a 0.5 into 10 to the power minus 3. 0.5 into 10 to the power minus 3 means this is a 0.5 0.5 into 10 to the power minus 3. It means, my dear students, it is a 500 second, or you can see here divided by 1000 multiplied by 10 to the minus 3. So, you can see here this 0.5 minus 3, yes, 10 to the minus 3, yes, you can get that 10 minus 3, and this is a 0.5 into 10 to the power minus 3. So, my dear students, you can solve it and you can get the 500. So, your answer is C. In this way, my dear students, you can solve this and answer you can get the 500 second. You can get the answer 500 second. Now, we can see the question number 30. If the rate constant of for a first order reaction is k, the time t required for the completion of 99% of the reaction is given by. This question is asked in NEET 2019. First order reaction, you can see here, that is a k is equal to 2.303 upon t log a upon a minus x. Here, my dear students, 99% means a is equal to 99%, it means a is equal to 100, and a minus x, that equal to 100 minus 99. Now, we can solve this, the rate constant of k time t required for completion. Here he want the time t. So, you can put the t is equal to 2.303 upon k log 100 upon 100 minus 99, that equal to 2.303 upon k log 100 upon 1, means that equal to 2.303 upon k log 100. My dear students, what is the log 100? Log 100 means 2. When you see the log 100, and that is the log 100 is equal to, that is 2, and when 2 is multiplied by here log 2, you can get the value is 2. So, t is equal to 2 into 2.303 upon k. So, my dear students, you can see here 4.606 upon k, you can get the t, and this is the answer of your question. So, my dear students, you can go the answer D. Question number 30, you can go the answer D, because here t is equal to 4.606 upon k.